Welcome class to our lesson on AC circuits. This is part of a larger course on electrical trade theory in Zimbabwe. So AC current is current that changes direction. Okay, so from here, let's move on to AC circuits component. The first AC component that we have is a resistor. A resistor opposes the flow of current and does not result in a phase shift between current and voltage. Then from a resistor, we move on to inductors. Inductors produce what is called inductive reactance, which is opposition to the flow of current. And inductors result in current lagging voltage, isn't it? Or a lagging power factor. Then from inductors, we move on to capacitors. The purpose of capacitors is to store charge. And capacitors produce what is called capacitive reactance, which is opposition to the change of voltage. Then capacitors result in current leading voltage. So in short, inductors current lags voltage, capacitors current leads voltage. Then for AC circuits, there are various types of power with true power, reactive power, and apparent power. So true power, this is the useful power which is used. And the formula is given by P equals to VI cos phi. Then we have reactive power, which is the power which is wasted. And it's given by P is equals to VI sine phi. Then we have apparent power. Apparent power, it is the power that we pay for. And it's given by P equals to VI. So in AC circuits, if you're asked to find power, most likely they're referring to true power. So you need to use the formula P equals to VI cos phi. Then as we are talking about power, we have something called power factor, which is a ratio between true power to apparent power. So power factor is also given by cos phi. So most industries use electrical motors which contain inductors. So most industries have a lagging power factor. So to correct the lagging power factor in industries, we need to use capacitors because capacitors have the effect of a current leading voltage. Then from power factor, we move on to efficiency. Efficiency is output over input A times 100. Okay. So now let's do some calculations. So let's say we have a series circuit, then with a power source, a source of AC, a current and voltage, and it's a 220 volts, and it's 50, and it has a frequency of 50 hertz. Then this circuit is made of a resistor, it's made of an inductor, and it's also made of a capacitor. So the resistor is 20 ohms, the inductor is 40 millihenries, then the capacitor is 60 microfarads. Farads. Then the question wants us to calculate the impedance. So the question is saying find a total impedance. Find total impedance of the circuit. So to find the total impedance of the circuit, first of all, we need to find the inductive reactance. So inductive reactance is the resistance of the inductor. So inductive reactance is given by XL is equals to 2 pi FL. So we're saying XL is equals to 2 pi. Our frequency is 50. Then our inductance is 60 millihenries. Then we find XL. So if you do your maths, you find your inductive reactance is 18.86 ohms. So after finding inductive reactance, we now need to find capacitive reactance. So capacitive reactance is given by XC. So XC is equals to 1 all over a 2 pi FC. So XC equals to 1 all over a 2 pi multiplied by 50, then times 60, then micro means times 10 to the power minus 6. So our capacitive reactance is a 53.03 ohms. After finding the capacitive reactance, we are now saying the formula for the total impedance Z. So total impedance Z is given by a square root of R squared, a square root of R squared plus XC minus XL a squared. So if we substitute values, Z, which is the total impedance, is given by a square root of our R is our resistance is 20. So it's 20 squared, then plus XC, which is 53.03, then minus XL, which is 18.86 a squared. So our total impedance for this circuit is equals to a 39.64 ohms. And just to calculate the voltage in the circuit, we just use Ohm's law. Current equals to voltage over impedance. So current equals to voltage over impedance. So current equals to the voltage, which is 220, divided by the impedance, which is a 39.64. The current in the circuit is 5.54 amps. Okay, guys, we've come to the end of the lesson. Like, share, and subscribe. And don't forget to download the books in the description below.